Did you know that a fuel truck carrying thousands of gallons of gasoline would explode catastrophically if it had sharp corners? While regular box trucks safely transport everything from furniture to electronics, a rectangular fuel tanker would literally tear itself apart on the highway. Today, we're looking at fuel trucks and why they have that round, tube-like shape. We'll show you how these big trucks are built to safely carry dangerous fuels like gasoline and diesel on our roads. Make sure to watch until the end, because we'll show you the hidden parts inside the trucks that stop accidents from happening. And if you like learning about trucks, make sure to click on that subscribe button. Let's start with the main reason fuel trucks have that rounded tube shape. It all comes down to how liquids behave when they're inside containers. Think about a regular box truck carrying furniture or packages. Now all those solid items just push down because of gravity. The walls of the truck simply keep things from falling out. Pretty simple, right? But liquids are totally different. When you fill a tank with gasoline or diesel, that liquid pushes out in all directions at the same time with equal force. This creates problems that solid cargo doesn't cause. Look at what happens when you fill a water balloon. The water pushes out evenly in every direction, making that round shape that we all know. If you try to make a square water balloon with corners, those corners would be under a lot of stress and would be the first spots to pop. You can see the same thing with soap bubbles. They always form round shapes because that's how pressure spreads out most evenly. Now imagine the same idea, but with thousands of gallons of gasoline moving at highway speeds. The stakes obviously become much higher. Any weak spots could lead to big problems. Engineers learned long ago that round shapes handle internal pressure from liquids much better. The curved surface spreads force evenly without creating weak points that straight edges and corners would make. This isn't just for fuel trucks. It's why soda cans, water tanks, and chemical storage tanks are all rounded too. A perfect sphere would actually be the best for holding pressure, but spheres make terrible vehicles on roads. The cylinder is the best middle ground between good pressure handling and practical transportation. Many people think the round shape just makes fuel tanks easier to build. While cylinders are simpler to make than complex box shapes with reinforcements inside, the main reason is safety, not manufacturing. Now that we understand why these trucks are round, let's see what happens when they're actually moving on the road. Now let's talk about something that makes driving a fuel truck way more dangerous than driving a regular truck, and that's liquid inertia. This hidden force creates challenges that most regular drivers never have to even think about on the road. Inertia is when objects want to keep moving how they're already moving. You feel this every day in your own life. When your car stops suddenly, your body keeps moving forward until your seatbelt catches you. Now that's inertia at work. With solid cargo like boxes or furniture, things might shift a little when the truck stops, but they mostly stay put where they were loaded. Liquid acts totally different from solid cargo. They never stay still when the vehicle moves. When a fuel truck driver hits the brakes, all that liquid keeps moving forward with huge force. It doesn't care that the truck is trying to stop. This creates what drivers call a surge, a powerful wave of liquid that slams into the front of the tank with incredible power. This sudden movement of thousands of pounds of fuel can actually push the entire truck forward, making it harder to stop, and sometimes causing the driver to lose control completely. The same problem happens during acceleration, with the liquid surging backward against the rear of the tank. During turns, the liquid pushes strongly to the side of the curve. Now this side surge is especially dangerous because it can actually tip the whole truck over during a turn if the driver takes that turn too fast. Now those slow trucks on curve signs that you see on highways exist mainly because of this liquid movement problem, not because truck drivers are being extra careful for no reason. These forces are so powerful that driving a tanker requires special training and certification beyond what a regular commercial driver's license teaches. Imagine trying to control a vehicle where the cargo itself is actively fighting against your driving decisions. Every time you brake, accelerate, or turn, thousands of pounds of liquid are shifting and pushing against your control of the vehicle. It would be like trying to drive a truck while an elephant inside keeps running from one end to the other, throwing its weight around unpredictably. The physics of liquid movement creates another problem too. The sloshing doesn't happen all at once and then stop. The liquid actually keeps moving back and forth several times after each driving change. This means even after a driver brakes, the liquid might surge forward, then backward, then forward again in smaller waves. These multiple surges can catch inexperienced drivers off guard just when they think they've regained control. This is why tanker trucks move so carefully on the road. What looks like slow, overly cautious driving is actually skilled professionals managing powerful physical forces that could easily lead to deadly accidents if handled incorrectly. Every turn, every stop, Every acceleration must be planned and executed with these liquid forces in mind. Temperature and tank fullness also affect how the liquid behaves. A half-full tank allows more room for the liquid to move and creates stronger surges. Different liquids have different weights and flow rates, which changes how they move. Gasoline behaves differently from heavier oil or lighter chemicals. Tanker drivers must understand how their specific cargo will react in different situations. The next time you see a fuel tanker on the highway keeping wide distances between vehicles or taking turns very slowly, remember they're not just being cautious. They're actively fighting against thousands of pounds of moving liquid that wants to take control of their vehicle with every change in speed or direction. Those physical challenges are impressive, but wait until you see the ingenious solution engineers developed to tackle them. And if you're enjoying learning about these engineering marvels, make sure to click that like button and subscribe for more videos about the hidden science behind everyday objects. So how do engineers solve this dangerous liquid movement problem? They use a clever internal design called baffles. This simple but effective solution makes tanker trucks much safer on the road. Baffles are metal walls inside the tank that split the liquid into smaller sections. Think of them as dividers that break up the huge amount of liquid into smaller, more manageable parts. These aren't solid walls that completely separate the tank. They usually have holes that let the liquid flow slowly between sections during loading and unloading. But when the truck is moving, they stop the liquid from sloshing all at once. So instead of having 8,500 gallons moving as one giant wave, the liquid gets divided into many smaller sections. When the truck brakes or speeds up or turns, only a small amount of liquid can move at any given time. This makes the surge much smaller and gives the driver much better control. Most fuel tankers have several baffles spaced throughout the tank. Some newer designs have both sideways and up and down baffles, creating a maze-like structure inside that limits liquid movement in all directions. Engineers carefully place the spacing of these baffles based on what type of liquid the tank will carry. But baffles do more than just control liquid movement. They also make the tank stronger overall. By connecting the top, bottom, and sides of the tank, baffles provide support that makes the entire structure tougher in crashes. This extra strength matters a lot because tanker accidents can be really bad. A study from 2009 found that while tanker trucks make up only about 6% of commercial trucks on the road, they cause nearly 31% of deadly truck accidents. Baffles are truly a life-saving technology that most people never even know are there. The baffle system has gotten better over many decades. Early tankers had very basic baffles that helped somewhat but still allowed too much liquid movement. Modern baffles come from lots of testing and computer models that show exactly how liquids move inside tanks during different driving situations. Engineers have to balance several things when designing baffles. If the holes in the baffles are too small, it takes too long to fill and empty the tank. If they're too big, they won't effectively control liquid surge during driving. The thickness and material need to be strong enough to handle the constant stress without adding too much weight to the truck. Some special tankers even use different baffle designs in different parts of the tank. The front section might have stronger baffles since it faces the most force during braking. Next time you see a fuel tanker on the highway, remember that inside that smooth metal cylinder is a carefully designed system of baffles working quietly to keep everyone safe by controlling the powerful forces of liquid in motion. Now that you know how baffles control liquid movement, let's explore the amazing variety of tank trailers on our roads. Not all tank trailers are the same. The design changes a lot depending on what they carry, and this happens for very good reasons. Fuel tankers, which we've been talking about so far, are usually made from aluminum or stainless steel to stop rust from forming. These materials are important because even tiny bits of rust could get into the fuel and cause some serious problems. The rust might damage car engines when people use the fuel. These tankers often have separate sections inside divided by complete walls, not just baffles with holes. This design lets them carry different types of fuel all at once. They can transport regular gasoline, premium gasoline, and diesel fuel all in one trip, which saves time and money. The engineering gets even more specialized for other kinds of liquids. Think about tankers that carry milk. These trucks are almost always made from high-quality stainless steel and must meet very strict cleanliness rules. They have special cleaning systems that can wash the entire inside between loads to make sure that nothing gets contaminated. Many of these trucks also have cooling systems to keep milk cold during the entire journey. For chemical transport, the engineering becomes even more complex. Chemical tankers are often made from special materials designed to resist damage from strong acids or other harsh chemicals that would eat through normal metals. They have advanced air systems to prevent pressure from building up inside. They also have specialized equipment for loading and unloading that reduces the risks of spills or people being exposed to dangerous materials. Compressed gas tankers take the cylinder design to an extreme level. These specialized tanks must handle enormous pressure from inside and basically work as pressure vessels on wheels. Their walls are much thicker than regular tankers, and they're often built from very strong steel mixes. The cylinder shape is absolutely necessary here because it's the best shape for containing pressure safely. Any corners or flat spots would create weak points where the tank could burst apart with terrible results. Tank trailers also vary in size depending on what roads they'll travel. Some countries and states have different rules about how big and heavy trucks can be. Engineers design different sized tanks to match these rules while still carrying as much liquid as possible. Now, some tankers are short and fat to handle weight limits, while others are long and narrow to meet length restrictions. The connection between the tank and the truck itself is another area where designs differ. Some tanks are permanently attached to the truck frame, while others are separate trailers that connect to tractors. Some even have multiple connection points so that they can be pulled by different types of trucks. Loading and unloading systems vary widely too. Some tankers load from the top, others from the bottom. Some have pressure systems that help push the liquid out, while others rely on gravity. The exact design depends on what's being carried and how it will be used. Tank color might seem like just a style choice, but it's actually functional too. Many fuel tankers are silver or white to reflect heat and keep the fuel from getting too hot in the sun. Some chemical tankers are specific colors to quickly identify what dangerous material they carry. This helps emergency crews know what they're dealing with if there's an accident. Even the shape of the ends of the tank can be different. Some have rounded ends on both sides, while others have flat ends or one rounded and one flat. The shape affects how the liquid moves and how the tank handles on the road. All these specialized designs show just how much thought goes into making sure different liquids get transported safely. Each type of tank trailer represents years of engineering experience and safety improvements. Next time you see different types of tankers on the road, you'll know they're not just big cylinders. They're highly specialized vehicles designed for very specific jobs. Those specialized designs are fascinating, but you won't believe the strict regulations and safety measures that govern these rolling hazards. The design of fuel tankers isn't just about what engineers think works best. It's heavily controlled by laws in most countries, and for good reasons related to keeping people safe. In the United States, the Department of Transportation has many detailed rules just for tanker design and how they must operate. Similar strict rules exist across Europe and most other developed countries. These rules cover everything from how thick the tank walls must be to what types of valves can be used. The rules require regular checkups, pressure testing, and official approval of tanks to make sure that they stay safe. Drivers must get special additions to their licenses specifically for driving tanker trucks. One of the most interesting safety features you might have noticed on many tankers is the separate compartments in their design. Beyond controlling liquid movement, these compartments also limit how much fuel could spill during an accident. Many rules set maximum sizes for these compartments, based mainly on this safety concern. The safety record of modern tankers is actually quite impressive. Despite carrying billions of gallons of dangerous materials every single year, serious problems are surprisingly rare. When accidents do happen, they're usually caused by traffic crashes damaging the tank, rather than problems with the tank design itself. According to official numbers from the government, tank trucks have one of the lowest rates of cargo-related incidents among all types of trucks on roads today. This good safety record shows how effective their design is and how well the rules are working. The rules don't just cover the physical design of the tanks either. They also set guidelines for driver training, driving hours, routes that can be used, and even what weather conditions are safe for transport. Some cities have special truck routes that tankers must follow to keep them away from crowded areas. These routes are chosen to reduce risk to the public if an accident were to happen. Speed limits for tankers are often lower than for other vehicles, especially on curves and ramps. This isn't just a suggestion, but an actual legal requirement in many places. The way liquid moves inside the tank is directly addressed in these speed rules. Emergency planning is another important part of tanker rules. Companies that run these trucks must have detailed plans for what to do if something goes wrong. Drivers receive special training in emergency procedures, and many tankers carry special equipment for containing small spills before they become bigger problems. The thickness of tank walls is carefully figured out based on what will be carried. Heavier liquids need stronger tanks. Harsh chemicals need special linings. These requirements aren't left up to the manufacturer to decide. They're spelled out in specific detail in the rules. Even the welding used to build tanks is strictly controlled. Each weld must be tested using methods like X-rays to ensure that there are no weak spots. The welders themselves must be specially certified for this type of work, and their certification must be regularly renewed through testing. Valves and hatches on tankers have multiple safety systems built in. Many have automatic shutoffs that activate if an accident occurs. Some have special breakaway features designed to seal the tank if the valve gets damaged. These small parts are actually engineering marvels, designed to work perfectly in emergencies. Checkups for tankers go far beyond what regular vehicles need. Besides yearly inspections, many tankers undergo tests where the entire tank is filled with water and put under pressure to make sure it can handle extreme situations. Any tanks that show even small problems during these tests must be fixed or taken out of service. All these rules and safety features work together to create a remarkably safe system for moving dangerous liquids on public roads. The fact that we rarely hear about tanker accidents in the news shows how well these systems actually work. Now, those safety measures are impressive, but wait until you hear about the latest innovations in tank design. If you're finding this information valuable, take a second to hit that subscribe button. We've got plenty more fascinating engineering explanations coming your way. While the round shape stays the basic design, fuel tanker technology keeps getting better in cool ways. New materials science is making tanks lighter but stronger so that they can carry more fuel while weighing less. This helps save gas. New aluminum mixes and even some plastic-like materials are being tested. These new materials could change how tankers are built in the coming years. Computer programs now let engineers see how liquid moves inside tanks really well. This helps make better baffles. Some new tanks have complex baffle patterns made with computer assistance. These new designs stop liquid from moving around better than old designs did. Safety systems are rapidly getting better too. New tankers often have systems that can tell when the truck might tip over and then brake certain wheels to stop crashes. Other systems watch the tank's condition and warn drivers about problems before they get bad. Loading and unloading methods are also improving. New systems help keep people safe from dangerous fuels while making the work faster. Special systems now catch harmful fumes during loading and unloading, which helps workers stay healthy and keeps the air clean. Self-driving tech might make tankers even safer someday. Self-driving systems don't get tired or distracted. These are big deals when moving dangerous stuff. While fully self-driving tankers aren't on roads yet, the tech is certainly growing fast. One cool new thing is tank monitoring. New tankers have sensors all throughout the tank that can find tiny changes in pressure or heat. These sensors can spot problems long before people could see them. Some can even tell when metal is getting weak, so parts can be fixed before they break. Gas mileage is getting better too. How air flows around tankers matters more as gas gets expensive. New tanks often have smooth edges and air deflectors to cut drag. Some have special back ends that reduce air swirls behind the truck. Now, these small changes can use up to 15% less fuel than older designs. Environmental protection is driving new ideas as well. Spill prevention tech has gotten much better. Double-walled tanks give extra protection, with sensors between the walls that can find even tiny leaks before they reach the outside. Some systems can automatically close off parts of the tank if they find a leak. All these improvements work together to make tankers safer, more efficient, and better for the environment than old ones. The basic round shape stays the same, but almost everything else about these trucks keeps getting better through smart engineering and new ideas. Now, the technology is impressive, but check out these mind-blowing facts about fuel tankers that most people don't know. Did you know that a typical fuel truck can carry enough gas to drive a regular car around the Earth more than twice? That's crazy when you think about it. With 8,500 gallons of fuel and an average car getting about, say, 25 miles per gallon, you're looking at over 212,000 miles of driving in just one tanker. The biggest fuel tankers on roads today can hold up to 11,600 gallons and stretch over 70 feet long. Imagine that. Nearly a quarter of a football field rolling down the highway right next to you. And here's something that surprised us. Temperature changes really affect fuel volume. A tanker filled up in the chilly early morning might look like it lost fuel by afternoon just because the fuel shrinks as it warms up. Pretty wild, right? Now, that's why they don't just measure the volume. They actually weigh the fuel during delivery. Now, the aluminum used in modern tankers isn't just about making them lighter. It's also a smart safety feature. In a crash, aluminum is way less likely to throw sparks that could light the fuel on fire compared to steel. Little details like this can make a huge difference. You'd think with thousands of gallons of fuel that could catch fire easily, tankers would be exploding left and right like in the movies. But guess what? Tanker fires hardly ever happen in real life. The tanks have so many safety systems, and that round shape really helps protect everything, even in nasty crashes. When fires do happen, they usually start in the truck's engine or brakes, not the fuel inside. We bet you didn't know that tanker trucks often make deliveries at night. Makes sense when you actually think about it. Roads are less busy, so there's less chance of an accident. Plus, gas stations prefer getting deliveries when they don't have a lot of customers pulling in and out. Ever notice those chains hanging down from the back of tankers? They're not just there for show. Those chains actually ground the truck during loading and unloading to prevent static electricity from causing sparks. Simple but clever, right? And these tanks are built to last. About 20 to 25 years with good care. Pretty impressive when you consider the beating that they take hauling heavy loads day after day. Not to mention dealing with fuels that can be pretty harsh on metal. Now if you like this video, take a moment to click that subscribe button right now. Share this video with someone who's always curious about how things work, and leave a comment telling us which everyday engineering marvel about trucks you want us to explain next. Drive safe, and we'll see you in the next video.